So without further ado, I would love to welcome Sam Blackshear to the stage, the founder, creator of Move. Always great to have you here, Sam, and we're all looking forward to your presentation. So I'll jump off and I'll give you the mic.
Thanks a lot, John. It's excellent to be here. And as you said, I love seeing all the folks here who have taken the bet on Move and have been taking the bet on Move. I think it's been 6 years for me personally, and then 5 years since Move has been unveiled publicly. The community is growing, the language is evolving. I think we're in a good spot, but there's a long way to go. So excited to talk today about what we've been doing in terms of advancing the language this year in the effort that we called Move 2024. I'm the creator of Move and the co-founder and CTO at Mysten, but Move 2024 is a team effort working with the Move core and Move innovation teams at Mysten, as well as lots of feedback and ideas from the SWE developer community. First, I'll just start with a very high-level overview of all the different features that we've added or are adding in Move 2024, and then I'll continue into a deep dive into some of the most important features and the most nuanced features to give you an idea of how to get the best usage of them. The first headline feature is a very simple thing, method syntax. Instead of passing an object as the first argument to a function, you can, like value of C, you can say C.value instead. It's not rocket science, but it's a lot more ergonomic. It makes the code more readable and easy to write. Similarly, we have index syntax. If you're using vectors, if you're using dynamic field-backed collections, you don't need to call functions. You can just write the much more readable version where you use square bracket syntax and you use whatever expression you want to index into the collection. We've added positional structs. If you don't care to name the fields in your struct, or if the names wouldn't have meaning, you can just use the types and the compiler will come up with names for you. In this case, you have point. I could have named it X and Y, but instead I'll just use the types and the compiler will come up with those names for me. In terms of control flow syntax, we have breaks with values. So instead of just saying, hey, break out of this loop, you can say break out of this loop and yield the value 5. This is helpful in the expression-based philosophy that we have with Move syntax. A loop is an expression too. Of course, you should be able to break with the value as well as just exit the loop. We also allow you to have named loops. So if you have nested control flow and you're trying to decide where you want the break to go, you can name a particular point and you can say, please break to this point. And you can combine this with the previous feature to yield a particular value at the point that you go to. We've added package visibility. The old friend feature, I think, was quite confusing. You sometimes don't know which module should declare the friends and which one should write the friend functions. You don't have to write that anymore at all. If the visibility policy you want is that a function should be usable to other modules inside your package, but not to anyone else, you write public package and the compiler will take care of the rest for you. Similarly, we have default imports for the modules and types used most often, things like option, things like vector. You don't have to write those anymore. It's good because your module now doesn't start off with that. So going a bit deeper into more features, macro functions, which is one of the newest things that just came out this month and that I'll be going deeper into today. You can have closures, you can have a lot more expressivity, you can have stream programming. Like here's an example of a map function that applies a closure to each element of the vector. Enums, which are definitely one of the more anticipated features that we've been working on for a while. You can do pattern matching, you can do destructuring. You can have types that just have a much richer representation. These type holes, which intersect with macros in an interesting way, where if you want to do an explicit type annotation, but only a partial annotation, you can just use an underscore and the compiler will come up with that for you. Moving on, we have clever errors, where I think a common pain point for Move programmers is that you declare the error type, and then you have to come up with a number, and then you use the number, and it's not clear what the number means. And so now you can annotate a constant with error, and you can, instead of assigning to a number, you assign to an error message, which you can get back as a user, and then the compiler will come up with the error code for you. This makes it a lot more sane to write errors and to understand what happens as a programmer when you encounter an error. Named blocks are quite similar to the named break, where you can choose to return to a particular point and out of a block and then yield a value. And then, okay, the part 3 of the overview, I know this is a lot, but there's a lot of features. The team has been very busy. For IDE improvements, we've been doing a number of things, but the next big thing coming up is that there'll be auto-completion when you type colon or dot. That's type directed. The thing to the left of the colon or dot, the IDE will look at the type and fill in only the options that will be valid according to that. And then also auto formatting. we're doing this via an NPM package, so it's really easy to use in web IDEs and directly in VS Code, but also it'll be available via the command line or anywhere else that you care to use it. And then two things that we haven't talked about as much yet that we're very excited about, and I'll touch on briefly at the end, is we're working on having a proper, more cargo-like package manager where you can assign human readable names to packages. You can use these human readable names inside your move.toml, inside SDK function calls, and clients can also use them to show you nice package names instead of very obscure hex addresses. And this also makes it easier to not get fooled about which package is which. And then finally, a hot topic in the Move community for a long time, working on safe interfaces to enable custom transfer logic and many other use cases that aren't enabled by these other features. That's the high-level overview. Let's now go into each of the sort of three big headline features that are now available or just becoming available. So for method syntax, the idea is just in each of these examples, I'll show the big example on the right, and then on the left, we'll zoom in and look at particular features of what's going on. So here's a function call where I get a coin as an input, and I want to check that it's a payment function, and I want to check that I'm getting the right amount. And so before I would have had to call the coin function, call a function onCoin and pass payment as an argument, but now I can just call payment.value, which is a lot nicer. As I said, not rocket science, but boy, it really changes the way your code looks. And so the way this works is that under the hood, before I was going to call SWE coin value payment, and I would have also had to borrow payment because payment's an own object, but value wants a reference to an object. The compiler will take care of this for you when you use dot syntax. If you have a type, if you have an own type, but you need a borrow or a mutable borrow, it'll do the borrow for you. If it's doing a mutable borrow, you'll need to add a mute annotation on the parameter or the local that you're doing a function call on, because we think mutability should always be explicit, and you don't want to be surprised about some value being changed just by using more convenient syntax. Another situation that this helps with is we have this pub use where you can add aliases for function names. So this is very useful in situations where you have a module and it declares two different types, and both of these types conceptually has the same operation. Like we encounter this in SWE where we have object IDs. There's a UID and there's an ID. Both of these can be converted to address and to bytes, but before, the functions all have to have different names, so you'd have to write UID to address or ID to address and type the correct thing. Whereas what you'd really like to type as a programmer is just, I have the object in hand and I type dot to address. And so pub use allows you to do that. You can say use UID to address. You can say use UID to address as a function on UID and use ID to address as a function on ID. And then when you call dot to address on a value, it'll pick the right function and it'll just work. So this too is very convenient in these more complicated modules where you have a lot of different types to work with. So now going into index syntax. So a common situation is you have a container and it'll expose some functions like borrow or borrow mute, where you get back an immutable reference or immutable reference. And so before you would have had to pass the function name, now you can call dot borrow. That's nice, but it would be even better if you could just use index syntax like you do in other languages for arrays and vector types. And so indeed, you can now do this. And the way you do it is that you add an annotation to your function that says, I would like to be able to use this as index syntax for the first argument of the function. And then you can write the code like this. Instead of container.borrow key, you say ampersand container of key, and that's being translated to what you expect under the hood, and similar for mutable borrows. Of course, all the built-in collections, things like vector, things like table, things like link table, things like bag will automatically support this. And then if you write your own collection types and you want to use index syntax, you can add that yourself by adding annotations to the functions where you want to use that syntax. So that covers the new method and index syntax part. Now let's go a little bit deeper into macros. So in this example, we'll be looking at, this is just an example we'll go very deep on because it shows many of the different things that you can do with macros. So here we're trying to expose a function that applies another function called body to every element of the vector. And so let's break this down. The first thing that we'll notice is that the function declaration looks different. Instead of saying public fun, we say public macro fun to say, hey, this is going to be able to use the macro features, which are a superset of what you can do with a normal function. And the next thing you'll notice is there are all of these dollars. And so these dollars are saying this is not an ordinary parameter, it's a macro parameter that's going to be expanded by the compiler that's going to support all of these different macro operations. And so if something's in expansion mode, we're using a dollar. And if we're doing normal move operations on it, we turn it into a normal variable first. And that's why you'll see code like let XS equals $XS, and then we're allowed to call functions on XS and do non-macro stuff with it. And so in this case, what happens is the caller is going to supply the loop body, and then we write a while loop that goes from I to n, and then we apply the body to each element of the vector. So here's how you would use this, say, if you wanted to collect you want to do something to all of the odd numbers in a function. So we declare a macro function, we take in a vector, and then we're applying this function that is going to take a U64 as input and then do whatever. So this is calling the each macro we already defined. And then this is defining a lambda where it takes x as input. If x mod 2 is 0, we break out of the lambda, and otherwise we call the function on x because we know that it's odd. And so something important to note here is that this return, where is it returning to? We certainly don't want it to return from collect odd, and we also don't want it to return out of the each macro. We just want it to return out of this lambda itself, and then that'll have the semantics we want of advancing to the next element of the vector and applying the function there also. This has been one of the big pieces of work to get macros working, is that you really want the control flow to be same. Returns, breaks, etc. should apply to the enclosing lambda or to the macro, not to that. So putting this all together, now let's use our collect odd macro. We'll define a vector. Here we've gotten 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We also have a sequence feature, so you could enumerate this yourself, but just writing it this way for simplicity. And then you write a lambda that says, okay, take each of the elements of the vector and call pushback so you can collect them. And so if you run this code, what you get is exactly what you expect, a vector that has all of the odd numbers between 1 and 10. Okay, finally, let's go on to enums. So for enums, and you can have a struct type, or you can declare a new type with multiple variants. So here, the example code is showing you that I have a coupon that has a value inside, and then it also has an expiration time. Or instead of the coupon being value-based, maybe it can be percentage-based, where it has a basis points field that tells you how much off you should get. And then you also have an expiration in that case. And maybe some lucky folks get a coupon that just says you get the whole thing for free. And so let's break down how you would use this type. As before, the full code is going to be on the right, and then we'll zoom in with usage on the left. So you construct variants the way you're probably familiar with in Rust or other places where you've used enums. You use the enum type, and then you use a : and then the variant name. So if you want to create a value variant, you say coupon : value, and you pass in amount and expiration. For percent, you construct it like an ordinary struct where you pass in the names. Or if it's something like free that doesn't have any fields at all, then you do the obvious thing. Now, once you've got an enum in hand, and this is of course the point of enums, you have rich pattern matching and destructuring. So let's take a little bit of a look at what we can do with this. In this case, I get a coupon as input to the discount function, and I'm trying to figure out like how big should the discount be. And so I pattern match on the coupon. If I see a value, I can destructure the variant. So maybe in this case, I want to ignore one of the fields. I can do that with an underscore, and then I just want to extract expiration. And you can also use OR patterns to bind the same name to different values in different variants, as long as it's the same type. So here we're trying to make the expiration logic work in a generic way, both for value and for percent. So we use an OR pattern with this bar here. We bind to the expiration of value and their expiration of percent. And then we can use that value expiration in the body to follow. And so here we're using it, we could use it to the right-hand side of the arrow, or we can use it in what's called a match guard. You see here where you say this pattern match should only be applied if this condition evaluates to true. So here we're trying to say, oh, if the coupon is expired, then I should say that it has no value. And then we'll continue to match on value and percent values after this, because this particular branch is only hit if the match guard evaluates to true. So again, this is very much as you probably encountered elsewhere, very rich pattern matching and destructuring, rich guards. It just makes it a lot easier to write logic that is trying to do different things depending on what's inside your value. And then, of course, we have exhaustive pattern matching. So if I try to write code like this, the the compiler and also the bytecode verifier will tell me, hey, this isn't working. I need to handle the coupon free. And in this case, we do not. And so it'll tell you you need to add coupon free, and it won't compile your code until you do. And then once you add it, you've got exhaustive pattern matching, and the compiler is going to be happy with you once again. So quick summary so that covers the three big features. A quick summary of where we are in terms of what's already there, what's coming soon, and what's coming beyond what I've said. Today, we have method syntax, we have index syntax, macro functions just shipped this earlier this month. We are still in the process of macroifying some of the Sui framework and standard libraries, but there are PRs after that and should arrive very soon. These type holes and clever errors are already out there. July is a big month where a variety of other things are coming. The NUMs are in DevNet today. They're going to go to testnet in early July. And then depending on how things go there, they'll be in mainnet shortly after. The ID auto completion features and auto formatter features should also arrive in July. There's already an NPM package for the auto formatter. If you know where to look, I can share that one later as well. And in the near future, the .move package manager that I mentioned and safe interfaces are things that are on our mind. I want to conclude by going a little bit deeper into the safe interfaces topic, because again, this is something we've been thinking about and talking about at the beginning of Move, maybe one of the more controversial design choices. And I think it's something where we've actually made a lot of progress, but there's still a few things left to do. Let's think about when we talk about interfaces or traits or dynamic dispatch or whatever, I think there's really three different problems that we're thinking about that it might be solved. And we usually think of a lot of times folks will ask for a feature and they're not thinking about what is this feature for? What are the different things this could be doing or should be doing? In a Move, we've always done it this way, where we don't add features, we solve problems, and when we add something new, it's being added to solve a very particular problem, and we deeply understand what it's for and what it's not for. Three problems that interfaces might solve. The first one is permissionless composability. I think this is one of the key value propositions of Web3, where two different folks write smart contracts, they're not aware of each other. These two things are useful in conjunction, and they can be glued together without the permission of either of the original smart contract publishers, and ideally with minimal or no coordination between those folks. Another might be code reuse inside a trust boundary. Maybe I'm writing a math library, maybe I'm writing a cryptographic library. There's a bunch of things that say want to use the common algebraic structure. I don't just want to rewrite that for every different crypto library I have. Just want to have something that implements the add interface, and I write code that works for everything that has addition. And then the third one, and I think this is the more controversial one, is you want to do safe code injection across trust boundaries. There's third party, I'm writing some code, it's allowing a third party to inject code into the code that I'm writing, but I want to do this without opening myself up to reentrancy or to safety issues. And so if this sounds scary, I think it is, but it's also something that's very useful to be able to customize transfer logic and to do various other things. But it's very important to not take this most extreme feature of code injection and conflate it with these first two things, which can be achieved via other mechanisms. So I think basically we actually have the first two today, and then understanding how that is and why it's true helps us see what we're going to need for the third feature. For permissionless composability, I think this has been accomplished actually in an even better way than interfaces via PTVs or programmable transaction blocks. I've talked about this in previous talks, and there's lots of docs on it, but I think it's most illustrative to show how Sui developers are using this. There are these really powerful DEX aggregators on Sui where they do complicated things where you want to swap token A for token B, and they'll split your token into multiple pieces. They'll figure out which liquidity sources are going to get me the best deal. They'll recombine them, and they'll do these, and they'll do this across multiple hops and with these very complex routes. Here's just one example where, just to do a single swap, the input coin gets split 7 times and does 13 hops against 5 different liquidity sources. And the thing to note here is that these liquidity sources, they're all DEXs or order books, but they don't implement any common interface, and they don't know anything about each other, and they don't need to do any coordination. And this is possible because PTVs just are type-based mechanisms for letting you glue these things together at the front-end level without having to interfaces to do anything. Every time you call in these functions, it returns some objects, and you can plug those objects into the next function, and that just gets the job done for you. So I think this has solved one of the big problems that interfaces have otherwise solved, and you can see with these DEX routers and many other things in the Sui community that folks are really leveraging this to the hilt. So the second thing, the permissionless code reuse or code reuse inside of Trust Boundary, I think is something that macros are actually accomplishing. And so this is some dev feedback on macros from K-Class, who's an excellent DeFi dev in the Sweet community, where he said people who are looking at Move 2024 are talking a lot about enums, but there's actually a feature that is even more interesting than this that you'd normally use traits and interfaces for. And here, so he doesn't spill the beans, but really he's talking about macros. And here's why. Here's two examples of where macros are really being used basically as a kind of interface, where there's actually some code from the K-Class is written where the details of this aren't too important. So it's about slippage tolerance and DeFi. But the important thing is there's this pool object input that's untyped. It's using this type hole feature. And then this code here is calling pool current square root price x64, and then assuming that this returns a 256 and then doing something with it. Basically what this is doing is it's saying, I'm looking at current price, square root price x64 as an interface, and any object that implements this function and returns a u256, I'm going to use it and write some logic that's generic over it. Very similarly, the new math libraries in Sweet framework, again, we take an x and y, we're using this type hole feature, and then we're saying, oh, any x and y that support the mod operation, the division operation, I'm just going to write logic that's generic over those. Here too, this is using mod and division as interfaces, and it's just saying, this lets me do code reuse inside a trust boundary across anything that's going to implement these operations. So then the thing so I think we've solved this permissionless composability use case. PTBs have been around since February 23. Now with macros, we solved code reuse inside the trust boundary. So the last frontier in terms of interfaces is how do we do safe code injection across trust boundaries, which is something that we have a lot of ideas on, and I think is going to be coming into the language in some form soon. So that's all I had for today. Everything here is documented inside the Move book or the Move reference if you prefer a more detailed but drier picture from a language perspective. This QR code will take you straight to the Move book. Thanks so much for your attention, and thanks for inviting me to.
Thank you so much, Sam. Always great to have you here. You're always invited.